welcome to all the participants to day 2 of our faculty development program. I hope you all enjoyed and learned a lot from yesterday's session. Today we are happy to continue our learning journey with another expert talk. It gives me great pleasure to introduce our distinguished resource person for the day, Dr. R. Roopa Chandrika ma'am, Professor and HOD in the Department of Cybersecurity at Karpagam Academy of Higher Education, Coimbatore. She completed her bachelor's degree in computer science and engineering in 1997, master's in 2006, and earned her PhD in 2017 in the domain of image processing. She has 20 years of teaching experience. Her research interests include image processing, data mining, and data analysis. She possesses strong programming skills in Python and has hands-on expertise in MATLAB tools. She is also interested in web programming. Her research experience has led to several publications in peer-reviewed journals in the areas of image processing, data mining, and data analysis. Today, we are privileged to have her with us to share her insights and expertise. Now, I take great pleasure in handing over this session to Dr. Roopa Chandrika ma'am to lead us through this insightful and enriching talk. Over to Roopa Chandrika ma'am.
Good evening, faculty fraternity. Have a good day. I would like to introduce myself, even though Anusha had given me a short introduction. Thank you for Anusha, ma'am. I'm Roopa Chandrika from the Department of Cybersecurity. I'm from Karpagam Academy of Higher Education, Coimbatore, Tamil Nadu. I take this opportunity to thank this Guru Nanak team for the convener and co-convener, organizing secretary for giving me this opportunity to discuss about cybersecurity operations. So my topic today will be on endpoint security. Hope this will be a wonderful session for you all. I would like to tell you the takeaways which will be we'll be taking it today. I just want, because the topic is endpoint security, I just want to know, you all get you introduced with endpoints. And other than when you have endpoints, I also want to tell you about API endpoints. So when we have endpoints, we know there's a attack surface. It's a vast attack surface. Therefore, obviously, we require a security. So we are going to deal with endpoint security. That also you'll be taking it today. So in this, I've just given a case study. So I have used a microservice. So before giving the microservices, a short introduction on monolithic and microservices. And finally, I'm just going to end up the session with a small case study and how these microservices are going to help you for the endpoint security. Now, it's a wonderful graph which has been given by Strategy Analytics Research. So if you see this research forum, they have just given predictive analytics from 2007 to just to the 2025. You can see the number of devices that has been connected to the internet. If you see the graph, it is just growing in alarming state. From 2007 to 2025, we have about 35,000 million devices which has been connected to the internet. And apart from that, there is a prediction from this forum that there might be 50 billion devices which will be connected in 2030. So let's just imagine how many devices will be connected in the internet. Okay, let us say there are some devices. I'm just saying these devices can be endpoints also. So let me just tell you, there are some common devices that could be considered as endpoints, which we are using in our daily life. So few of them I've just listed in my PPT, like ATM machines, then IoT devices. We have industrial machines, laptop, medical devices, mobile phones, digital printers, servers, then laptops, tablets. So all these are few of the common devices, and they are endpoints. And it's a pictographical information we have given here. So all these devices which you are seeing now, all these are physical devices. So you can see all these, we are able to visualize this, we are able to touch this. So all these are physical devices. Have you ever imagined even an endpoint will be a software application? So there are API endpoints, there are soft APIs also. So how they are endpoints? Because these applications have specific URLs. So these URLs will make a request and also waiting to receive a response from the other services. So they also become an endpoint. See, when I say endpoint, you just think it's a software API. The Instagram which we are using is also a software API endpoint. Okay, let us say, okay, we all have the AI API endpoints. let me just give you the other software and APIs which we are using it. You can see we have a Twitter. It is also an API endpoint. Then we have these YouTubes. So we use it. We want to watch any video, we embed the code and get the video from the YouTube API. And then just imagine we want to listen to songs. Immediately we use a Spotify.com where you're able to hear these songs from different artists or any genre. So all these are API endpoints. So yes, there are endpoints. So what is the big great thing about the endpoint? Yes, we are using this endpoint. Then the big problem is data leakage and data breach. So data breach or data leakage. What is that? We have, now there is a common term which we are always using. There's a cyber attack, cyber attack. We have been attacked. There are people who are stealing money, grabbing everything from us, grabbing the data. So all these are cyber attacks which is going in the background. So now there is a statistics which says that uh, there is a cyber attack every 39 seconds. So totally we'll be having about 20, 22, 44 attacks daily. So remember how many attacks, just imagine with only these billions of devices, we have these attacks. So when the number of devices grow, obviously the number of attacks and the cyber attacks for every second will be growing alarmingly. So with these attacks, so who's the common target for that? Endpoints are the common targets. So that is why in the previous slide, we have seen that we have number of endpoints. These endpoints will become the common target. Now, these endpoints, they say that malware can be injected into it. If you have a malware, then they will crash your system. Then these endpoints will be a vulnerable entry point. Therefore, if it's vulnerable, then it is easy for a hacker to attack this. So if it's easy for a hacker to attack, obviously our data will be leaked. So endpoints, we have to be careful with the endpoints because we know that these endpoints are vulnerable and it will be so useful for the cyber attack or the hackers to get our data. So with this, I know we have seen what are the endpoints. Let us just have a short introduction about the endpoint. So endpoint devices, okay, all these endpoints we have. So what is the big thing? Why should we use this endpoint? Is it necessary for us? Yes, sure, it is necessary because it is making our lives very much easier. And more organizations with the more monolithic software which you have, if you have these endpoints, it runs more efficiently. For example, if you have a corporate organization which is being distributed geographically, and then we can also have this BYOD. You can bring your own laptop and use it anywhere. So that laptop will become an endpoint. But still, your organization will ask us to use a laptop at home or anywhere so that they can get the data. So we require these endpoints, but still it is creating it will become a vulnerable endpoint. So any hardware or any virtual application that is going to emulate this hardware will be considered as an endpoint. So you can see if there is a connection across a network, a message exchange in a TCP network, then that particular point will become an endpoint. So are there any devices that they are not endpoints? Yes, we also will see that. Now let us say we have a corporate network. We have all these endpoint devices which has been connected. Okay. And let us say that now this is a private network. Now, after this network, now let us say the organization wants to get connected to the globe or the www. So they use a router to get connected to the internet. So obviously now when it was a small network, then when it was safe, when you are now, we are visible to the internet, then obviously it becomes a vulnerable device. So now can you, from the previous slide, can we say that, okay, so the router will be an endpoint order because now we have seen a LAN and then a router gets connected to the internet. So can we say an endpoint that router is an endpoint? So there are some situations the router itself will become an endpoint. Say suppose the router plays its role as a web interface. So you have all the destination traffic there, then that will become an endpoint even though it is a device that is used for communication between the source and destination. And if that router plays another role, okay, it plays a dual role like a web interface, then that router will become an endpoint device. So a simple definition, just to simplify, what are the endpoint devices? So if a device does not have an IP address and it does not generate any data or consume any data, then it will you can term this as an endpoint device. So just think, if you have any device, it's able to generate your data, it's able to consume your data, then it will become an endpoint device. So simply as we said that, say suppose you have a mobile phone and you have a Instagram or you have your Spotify app, and then you're going to send some messages through the Twitter or Facebook, then it says that you're generating some message, and then you're floating in the web. So that will become an endpoint. So if you're not doing anything, you don't have any apps, our life will become so difficult. Yet we have to use these just to make our life easier. So we require endpoints as well as we have to secure our network. So since, as we told that we have number of endpoints, we have to use it to make our life simpler, but yet we have to make it secure. So we'll see how to make it secure. So endpoints are particularly lucrative entry points for the hackers. We know very well, we have a number of entry points for the hackers. It will be also lucrative, because what they do is, if suppose there is a ransomware in the system, then your system will be hacked. Then they will ask you a lump sum amount. Then they will free you from your, they will grab the data, or they will free you from your device. So by asking some ransom amount. So it is vital for all the organizations to consider every device that is to be connected in the network, they must be protected. So even though you have laptops or any devices which is working outside the organization also, the organization must also keep in track of all these devices and ensure that all these devices are protected. So we know that, so you have number of endpoint devices, as we seen in the other slide, in the previous slides, you have number of endpoint devices, and the devices each and every day, the features are also very sophisticated. Each day we come with a sophisticated feature, and so our security solutions must also be parallelly evolved so that we can protect our organization. So now we see that the endpoint devices, they are sophisticated, and similarly, we must have the security solutions also to be evolved to match up with the sophistication of the endpoints. So we're going to see how to protect the devices. So obviously, when there are entry points which is vulnerable, therefore we need a device management. So there are a number of device management tools. So the first one, usually we say it's a zero trust model. Don't believe anyone. Okay, believe only in your system and believe the organization, and then we'll be able to protect the system. But is it always ideal? It is not ideal. But yet we use this model, zero trust model, so that we'll be able to safeguard our system. So to safeguard the system, what we have to do, all the endpoints must be visible. So if a corporate has about 10,000 systems, all the 10,000 systems must be visible. Only if it's visible, you'll be able to protect your organization. Okay? So for that, now you have to integrate this patch management, then data security and other incident response features. We have to integrate all these to make our systems safe and secure. So now all these we've done. Okay, now I have a corporate organization where it is we have been using some legendary software or traditional software, and that software was a monolithic placed in a monolithic architecture. But still, I want to protect my devices, all the endpoint devices. So what architecture can I use? So I can enter into a microservice architecture. So there are two diagrams in this slide, which shows the monolithic architecture and microservice architecture. So on the left, if you see the monolithic architecture, now there are three tiers you have. You have your user interface, you have your data interface, and you have your business layer. So we know that we are always going to keep our business layer very protected. And these business layer and all these three are going to communicate to the database, where you have the important data which has been safeguarded. Now, if you look at this monolithic architecture, user interface, data interface, and business layer, all these are clubbed into one single soul architecture. So If any changes made in the user interface is also going to reflect your data interface. Similarly, if any changes in the data interface is going to reflect your business layer. Similarly, all the three, any changes made in all the three will reflect the entire system. So that is the biggest disadvantage of the monolithic architecture. But now in the recent technology where you want to protect your devices, endpoint devices, so this monolithic architecture is not going to help us. Obviously, we have to switch on to this microservices architecture. So if you see the right-hand side of this picture, you can see this user interface. Okay, and you have number of microservices, and see all are being independently placed. Each microservice will be having a connectivity to the database. So this diagram itself tells us that one microservice is independent of the other. So any changes made in the microservice 1 is not going to affect the microservice 2. So similarly, for the other microservice, how many other microservices on the system? All the microservices are independent. It is not going to affect if any changes are being done in one microservice. And each one will have its own database. So any changes made in one DB is not going to affect the other. So you'll be having like a separate system being working. It just gives an illusion that a separate system is being working. So microservice architecture breaks down the traditional monolithic software. That's what the diagram itself is going to tell us. And this deployment model to be independent. So independent, as I told you, we have all the microservices are independent. Independent in the sense, any changes made in one microservice is not going to affect the other one. Okay? And it can be deployed and can be scaled. So I'm having a microservice. My organization has deployed one microservice. I can also scale it to 100 or 200 services. So it depends upon the organization strength. A brief introduction about the microservice. So we've seen the advantage and disadvantage of monolithic architecture. Now, in the previous, traditionally, we had used monolithic architecture where the technology did not support us for this type of architecture, microservice architecture. We had to build a monolithic architecture with the technology present. So hence, we had the traditional monolithic architecture. And now because of the advancement in the technology, now it is easy for us to switch over to microservices. So again, the repetition of these words again for the microservices. It is small independent services within an application. So each microservice perform a different function. So say, for example, if it's a payment gateway, that will be done by a microservice. If you want to authenticate a user, then that will be done by a microservice. If you want to verify a digital signature, that will be done by a other microservice. So all microservices will perform a different function. So, and all these microservices will be able to communicate among each other with a common API, okay, a lightweight API. And the works on the services, they are responsible for without affecting the rest of the application. So as I said that if any changes done in one service, it's not going to affect the other one. And in the previous slides, we had seen that each microservice will be communicating to a data storage. So any changes done to this DB is not going to affect the other one. And microservices that can be developed in any programming language. So it doesn't stick on to only one language. So that makes the flexibility and scalability of microservices. So all these points which have been given here says that microservices are very flexible and very scalable. So now we are bringing into, all the organizations are bringing these microservices into their organization to make it easier. So as we now, this is a diagram to show you a scenario. Okay, now let us say it's a common scenario where a client is going to communicate to a server. Okay, usually this is a communication we do. We have a client communicating to a server. The client request, and we expect the response from the server. So this is a simple scenario. Let us assume this simple scenario. Now let us say in this diagram we have a client. Okay, and he wants to get the service from the server. So this client, before getting the service, now he will be now protected by an API gateway. So he has to communicate to the service only via a API gateway. And then this API gateway in turn will send the request to any one of the microservice. So whatever the request, the corresponding microservice will be called for. Okay. And the microservice will do its functionality and then return back to the API gateway. The API gateway sends a request to the client. So this is the the scenario which we usually do for any communication. I repeat this. We have a client. The client asks for a request to the server. Then we have in between the client and the server, we have an API gateway. So this API gateway will be now getting the request from the client, and then it can use another microservice to check whether the client is an authenticated client, whether it is a genuine person, whether he has gotten any authenticated credential. Okay, the API gateway will also check whether the client is authenticated by using his checking his um, credentials, user credentials. And then we can have another microservice for the request the client has asked. The service has to be given by any microservice. So I've just giving this scenario where we are going to work with. We are going to use a postman so that we'll send messages through the postman. Then in this gateway, we have used a port 5004 and for microservice 6004. Just keep in mind when we go on for the future slides. So we have the client where the client will be sending a request and the API it is going to the API gateway. So API gateway is open with the port 5004. And then the API gateway will now proceed to the sending the request to any one of the microservice, and one of the microservice is open with the port 6004. So this is the scenario. For this scenario, we are going to develop build a microservice, endpoint security microservice. So now this session is developing a microservice for an endpoint. Okay, I'm just repeating. Now this session we are going to develop or build a microservice for the scenario which it is shown here. So we have a client, we have an API gateway, and we have microservice. So this is what we are going to build. So for this, I'm using a Postman. So the website used for developing this microservice, I'm using a Postman. It is very easy for building and for testing my API. The website is www.postman.com. So now it can be downloaded depending upon your operating system. Now I have downloaded because I have used a Windows platform here. So download from the website. It is easily downloadable. Now this is one software requirement. The other one is for developing this microservice. We have used a Go programming language. Okay, it is an open source programming language. Very easy, very quickly. It can develop quickly. You can develop an API, and it is very easy to communicate between the microservices or APIs. This language has this flexibility to communicate with the APIs. One bigger advantage is now all the messages which has been conceived will be in byte format, and then you can transform it into string format. And again, vice versa, from the string, again, you can take it to byte format and do the necessary communication. So since this is an easy communication and Go programming language gives us this flexibility, we are using this Go programming language for developing this microservice. You can also take this as one of your developing a microservice picture. Okay. Now, the number of companies are right now using this programming language because it's got an easy syntax also. Before developing a microservice, I just want to tell you, just to give you what are the important commands that we actually require. Now, Go is the language which you're going to use. To start with, we use the Go command, Go, and mod is your module, and the init command. So we always know we have to initialize any modules. So this is the command to initialize go mod init. So this command, now this module is the module path, you have to give the module path. Now you can create a package, and then that package name you can give it in your init command. So go init and your package name. Now if you see, say suppose I have a package called example.com, and this is the greetings endpoint which I have. Okay. Now in this language it uses a double slash for comments. Now this is the basic Go language commands. Now let us start with a small program. Now let us say we are going to declare a greetings package. Okay. So declare a greetings package, use the keyword package, and the package name, it is greetings. Then say this package, it is going to send greetings. So obviously it requires some printf function. And there is a format package. Like in other languages, we have packages. If you use Python, there are some packages. If you use Java, there are some packages. So you have the input library and you can use the functions. Similarly, this Go language, we have this concept called a package. So this is a user-defined package. It is greetings. And this greetings is going to send a message. Hence, for sending a message, we need a printf function. So for this printf function, we have to use the format package. So there is a keyword called import, and then what package we are going to import. So FMT is the package which you're going to use for printing. And then this package is going to have one function. The function is a hello function. So we have the keyword called function, and what is the name of the function is going to be hello. The argument is going to be a string, and then the return type is going to be a string. So simple syntax for a function is, so in the package greetings, we have a function called hello. Then this hello will take a string as an argument and is going to return a string. Okay. So since it's greetings, it just colloquially said that we are going to return a greeting. The function takes this name as the parameter and the data type is a string, and it also returns a string, right? So in Go function, if you see, if the function name is given in a capital letter, then it means that it's a global function. Now, in this example, now greetings is the package, and we have a hello function. So greetings can use this hello function. Since it's global, any other package can also use this function. So it's a global function. So in Go, a function whose name starts with a capital letter, then it's a global function. So other than this greetings package, any other package can also utilize it. Okay. So we are going to declare a message. So declaring a message is, as usual, you give a variable name, colon equal to, okay. And now this is declare, and we are going to initialize it. So since the return type is a string, so message is equal to format sprinter, and whatever string which want to print, we are going to print it. So we have an operator equal to, which will initialize and also get the value from the printf function. So hi, and there is a action verb here. So this action verb, whatever input the user is going to give, that is going to be stored in this %v. So hi, the greetings which you're going to say, and then welcome and give it the name. So this is a simple function in greetings package. Now, as he said that why Go language is being used for microservices now, because we said that because to ease the transmission, all the content transmitted in bytes are converted to string, and then the string and vice versa, and the string can be converted into byte. So we have in Go language, we have marshal and unmarshal, where this particular transformation is being done, where you want to convert a byte into some text format and back text to a string format. So that is why they prefer this language, because it makes the communication a little bit easier. So I said that you have some structure, okay, some data structure you have, okay, and then this is the byte you wanted. So you have this byte, unmarshal, and get the structure, or the structure or any data type. It can be map, it can be list, it can be structure, any data structure. So we also have map, list, and arrays. All these are all available in Go language. Now, for simplicity, how we are using just a struct here. Now this, you just marshal it and you convert into byte. And then byte, again, you unmarshal it and then get back to its original data structure. So for doing this marshal and unmarshal, we have to import a package called encoding. Okay. And this is JSON. So we are using encoding / JSON. So in the previous case, we had used a printf function. So we used a format package FMT. And for marshal and unmarshal, we need this encoding JSON, import encoding JSON. The process of converting a byte stream into a Go data structure, marshal is processing an object into a byte stream. Okay. So why we prefer this language? As I told you that now all the microservices, okay, can communicate with each other, and it will be easy for transmission over the network. So marshalling is suitable for transmission over the network and for efficient communication also. Now let us start the programming. Now I've just given a picture here, the previous slide which we had seen here. We have the client, we have the API gateway, and we have the microservices. Okay. So for example, if you want to develop this in using Go, now let us say we have a gateway and we have a microservice. If you can see, we have now uh, two folders we have created. One is for the gateway and one is for the microservice. So create a new folder called Go or any other name. It's user's choice. Then under this Go, we have two other folders. One is for the gateway, and the other folder is for the microservice. Hope this is clear. By looking at this picture, this architecture, we are going to create this folders. Now, under each folder, so previously we had gateway as one folder and microservice another folder, two folders. And inside this microservice, we are going to have another two folders. One is the command and one is the server. Okay. So command, and then we are going to have server. So automatically this Go, it creates other two files, Go file and Go sum. Okay. This is a summary of the log. All the logs will be saved in this go.sum. And we have the module file. Now in this command, we are going to have the main file. So let's begin. Now let us say we have the main function here, and this is the hierarchy, or this is the directory structure. So in desktop, I have created a Go directory. Under this Go directory, I have a microservice. Okay, microservice folder. Under this microservice, we have another folder called command, and this command will have main.go. Right. So I have a package called main. So like all other programming languages, here also we have a main function. So that's main. We name it as a package main. So we always begin with a package main. So in the previous slides, we have seen to initialize this, we say go mod init. So you have to initialize it. So how do you initialize? With the help of this package main. So for example, here we have given main.go. So you have to start with this main.go. So that hence to start with main.go, my package name also will be package main. So when this package main, now what happens is, now we have to communicate to the server. So we said that this microservice will be having two folders, command and server. Now in this command, you have a main function. Okay. In this main function, automatically calls the server function. So main function server.rest server. Now, in the previous example, we have seen a hello function. It was a global function. Whereas here we have a main function. It is local to the main. Okay. So to start with, we have the main. In this main function, we have a REST server. Okay. So we are going to call the server function. And for printing, since we are in this function, we are using a print function. Therefore, we are importing FMT. Now, here we are communicating to the server function. The server function is in the folder microservice and server. Okay, this REST server is in the folder server, and the parent of server is microserver. Now, this server, if you look at this server is a function which returns an error. So in this programming language, it very well handles errors. Okay, exception handling is done very well. Error handling is done very well. Therefore, this function, if it returns an error, obviously you have to handle the error. Therefore, error is equal to server.rest server. So now if the server gives you an error, automatically we can now catch it, and then we can find out that there is an error in the server with the help of this error variable. All right. Now we have the parent folder gateway, and inside the gateway folder, we have a command. Then in the command, we have main function. That is what we have seen in the previous slides. Okay. Now, in the server subdirectory, as said in the previous example, in the gateway, we have command and we have main dot go. This gateway also has another subdirectory called the server. In the server, we have server go file. In the server .go, we have a REST server. Okay. Now, the REST server, what it does is, if suppose the server, it doesn't uh, sends the request or does not find a service for the request asked, then it returns an error, because the server function is to return the request asked by the uh, client. If doesn't return a request, then obviously returns an error. Now, for routing, now we say so we have, so far we have seen a client, you have a API gateway, and you have a microservice. Now for this you need a router for this. So you have to create a new router. So Go language gives us a flexibility to create a router. Okay. So for this you need a multiplexer. For multiplexer, short form is MUX. So MUX dot new router. This is the command in Go language. Okay. So this router in the sense, the new router which you have created is the main router for the web application, because this router data only is going to be passed to the server. Okay. And so all the HTTP communications will be done with the help of this router. It will help the handling the request service and requests. So for this new router, we require another package called net/HTTP. So we've seen number of packages. First, we've seen a FMT package. Then we had seen, now we are seeing net/HTTP, because we have to import this function new router. Okay. This you can get from a GitHub. If you want this router, you can get it from GitHub. So just Google search and see Gorilla Mux. You can find out this Mux, and then download this package in your Go folder. Okay. Now this Mux, because it's a router, it handles the HTTP request and writer. If you see the function here, W is the variable, that is the response writer, and R, it is a pointer to the request. So you get the request and then you give the response. So simple HTTPS request and response function. So there is a function where it get the request and then responds it. So for getting the request, you have R, and for getting the writer, you have a W. Okay. Now this is the postman here. So we said that, so far we were talking about endpoints. Now where is the endpoint here? Now say suppose you're going to create, we have an URL. The URL says www.spotify.com/SP Balasubramaniam. So SP Balasubramaniam will be your endpoint here, because you're going to ask something from the Spotify.com. So similarly, now /create is going to be an endpoint. So I'm just getting again. Now, if you have, say, a YouTube video, if you want to get a YouTube video, or if you're going to send an Instagram post, so what is the post you're going to give? That will become an endpoint here. So similarly, here we have HTTP localhost. I'm going to use a localhost here, and my port is 5004, as I said in the previous slide, and create is going to be an endpoint here. Okay, so this is the endpoint. Now, when the endpoint is received, now you have to secure this endpoint. Okay, let us say this is the create is the endpoint, and you have to secure this endpoint. Now we had the main function. In this main function, we used to call the REST server. So from the main function, now we'll be having a flow to the server function. In this server function, we have the server. Now this server will return an error if the request is not satisfied. And as we said that we have to have a new router. This router will help us to handle the HTTP communication. So now router is equal to mux.new router. Okay. Now you have to handle the function. Now this is the endpoint we have. Now you're going to handle the function in the sense you're going to handle the endpoint. So this router dot handle the function. Create is the endpoint. If suppose in the URL you have this endpoint create, then obviously this function will be entering into a create resource. If you click on to create, then what should happen? Then do the functionalities as given in create resource. So what is the method used? It's a HTTP protocol. Therefore, we have functions like get to post. Now we are going to give a post method. So please look into this. We have a post method. We are going to post it, and this create is the endpoint. Okay. And when you click on to create, when the client gives this create, when you click on to create, then it must go to create resource. So what will your server do? The server will be always listening to the client, whether I'm getting any request. The server job is to keep on listening. Now here, since we have created a port of 5004, this server keeps on listening and captures this 5004. So 5004, as given in the previous example, was my API gateway. So this http.listen and serve, it will listen to this API gateway 5004. From where? From this router. So what is this router? This is the new router which we have created for this HTTP communication. Now this listen and server also will return an error function. So if there's no error, then no problem, then return it. If there's an error, then print the error. So if there's an error means then the server has found out some problem. If there's no error, then do the functionality what has been requested. Okay. So here the line 5 starts the web server. So the web server will keep on listening. So now it listens to the port 5004. Okay. Now, once in the previous slides, we have said that once you click on to this create, then it must go to the create resource. So what is the create resource? So create resource will have, so as we said that the function will be handling the HTTP request. So you have a response writer and we have a request. So for request, you are using R, and for response, writing the response, we use W here. Okay. Now look at this post command. Now post HTTP localhost and the port number /create. Okay. So this is the body. So now what does the body has? Now the body has some JSON variables here. It has map, data, and the value is my data. You have a key and its value. So in this body part, this is the body part. In this body part, we have a JSON structure where you have a key and its value. So keys are data, user, and endpoint. So data, the value is my data, and user is Amazon, and endpoint is microservice. So this data, I'm reading it using read all function. A simple function, IO read all r dot body. Okay. This r dot body also, this read all function is also going to return an error. Okay. Now this read all function is going to return two things. One is the body extracted, the other one is the error. Now this language gives us the flexibility to handle the errors. Therefore, whenever we write some functions, then obviously you have to write catch this errors. So if there's no error, then no problem. If there's an error, then you have to return. Okay. Now what we do is we have read all the contents from the body. Okay. So request body info. You're getting it. Okay. Now we have this data, user, and endpoint. All these are in JSON. So request body info is what is the structure you want. So data, I want this JSON data will be depicted as a data string. This JSON user will be taken as a user string, and this endpoint JSON will be considered as an endpoint string. So it shows the relationship, data and the mapping of this data to the data string, JSON user to the user string, and endpoint to the endpoint string. Okay. So when you give this request body.info, automatically data will be converted into string and then stored in this request. So now the request will have all this information with us. Okay. Now in this, now we said that we have to secure the endpoint. So how we are going to secure? So these are the things to make it secure. Now this is done hard code. It is done hard code is done because I'm just giving in this application, I'll be having only 2 admin users. So admin users is a string array. So there are only 2 users here. We have Madan and Prasad here. So there are only 2 users in this admin user. And the endpoints will be microservice 1 and microservice 2. So these are the constraints which you're going to give. So when the client request, immediately it comes here and checks and authenticates whether the credential is valid or not. So if the credential is valid, then the service will be done. If the credential is not good, then the service will be discarded. Okay. So these are the conditions. Now we said it's an endpoint security. Now this is the these two statements is going to secure our endpoint. So as I said that only two users can enter into the gateway. Those two users will be Madan and Prasad. Okay. And you can also have endpoints. So here we are given only two endpoints, microservice 1 and microservice 2. So if the request is Madan and Prasad as a user, and the request endpoint will be microservice 1 and microservice 2, then we'll be receiving the response. Otherwise, it will fail. Simple thing. Okay. So now we allow is whether the gateway can allow it. So initially it is false. Okay. Now what we're doing is, if you're getting the request from the user, if the users match the strings in the admin user, then the allow is true. Otherwise, the allow is false. Simple to say. First, initially, the allow is false because the gateway is a zero trust model. It does not allow anyone. Now, to allow someone, then you must have to give a constraint or you have to give a conditional check. So what is the conditional check? I'm just checking whether the request from the user, if it is inside the admin user, then you can allow it. And there's another condition also. If the endpoint is in my endpoints, if it is in my endpoint list, then I can allow inside my gateway. So as I said that if there are two users can enter and endpoints can two requests can enter the gateway. Okay. Now look at this. So create. Look at my data. I have my data. I have Prasad and I have microservice 2. So now if you see, my user is Prasad and it is inside this admin user. And I have microservice. That microservice is in admin endpoints. Therefore, if I give this endpoint HTTP localhost 5004/create, now this is a successful response because the user is what is listed in my admin user and the service also is also listed in my admin endpoints. Okay. Now, if suppose the user is not authenticated, then actually we have to throw an error, not allowed, and we get HTTP status, it's a bad request. Okay. Now, this coding is done using VS Code. So I'm just demonstrating my VS Code here. So you can see the left hand side. Hope you're able to see this. So we have a Go folder, and we have a gateway and microservice. Okay. Inside Go, we have gateway and you have microservice. In gateway, you have command and then server. Similarly, in microservice, you have two other subfolders, command and then server. In command, we have main.go. In server, you also have server.go. Okay. So in the PowerShell, I've already initialized the package. So from PowerShell, it's already translated to Go. Okay. Now, say I'm going to so I'm in the gateway now. Okay. So in the gateway, I'm just executing main.go. I'm going to my postman. Okay. This postman, in this body, I've given data as my data. User is I've given Roopa and the endpoint is microservice 2. Okay. So what do we expect is I'm just sending this. Okay. And I'm going to my microservice and executing the microservice here. If I give this service now, right? So Prasad was a valid user. So the microservice received was some data it has received. Okay. Now, if my user was another fellow. Okay, it's not authenticated. Okay. So previous case I gave Prasad, it was in my list, hard-coded list. So it gave me, yes, the user is an authenticated user. I was able to use the microservice. Now, if I give another user which is not in my list, then I get not allowed. So you can see the bad request. So it is the HTTP status request. HTTP status say 400 is a bad request because the user is not an authenticated user. Again, I replay this. If it's an authenticated user, okay. If it's an authenticated user, my status will be okay. Okay. And for Madan, what is the specific request asked will be given. So in this body, it's going to now check the constraint. If the constraint is valid or if the credential is valid, then I get this. Then the transmission is smooth. If the credentials are not satisfied, then it stops. So this is simple security, endpoint security that shows that it doesn't allow inside the gateway. Okay. So as I'm just again going back to this slide. So we had sent a create function and I used this 5004/create. And then here in this authentication, first time I had used Madan, and then the gateway said, okay, you're allowed, and gave me the request from the microservice. So in this microservice, the request was some string it had given it to me. And then in the second case, when I used Roopa, an unauthorized user, so the gateway did not allow. Okay. So create. Madan was the authenticated user. So the request was asked. The request asked was responded as needed by the client. So 200 is the status, HTTP status, which said that your response is a good, valid response. Now, the same thing, if I give invalid user in the sense it is not in my admin list. Roopa is not in my admin list. Then if I execute this, then it says it's not allowed. So I'm preventing the user, unauthorized user to enter into my gateway. So it gave me a bad request. Okay. So now we can see the security is enhanced. It is a simple code just to show that the security is being enhanced. So the users are not in the list, then the permissions are denied. So hence security will be achieved. So I thank this code was developed by my student. He's working in Abluva Technologies. So he just hard coded this and then has given it to you. Thank you all for patiently listening to me.